All right, and next up, our first town hall of the workshop on container technologies, moderated by our 2022 Flight Software Workshop Technical Chair, Chris Heistand. Chris, it's all yours.
And can I get the town hall panelists to come online as well? So I just wanted to introduce what we're trying to do today. The goal of this hour is to talk through container technologies, so things like Docker, Kubernetes, Docker Compose, Podman, and trying to get a gist of what we're doing across the space industry and engage those panelists with essentially whatever questions you come up with. So we're gonna do a quick introduction for each panelist, kind of what their background is, what their technology stack is, and then I'm just gonna take a Q&A from the audience. So if you have questions about containers, how we're using them, security around them, any of those, start lining up your questions, and I will help moderate. Next. First, I'd like to introduce Liz Rice.
Hi, thanks for having me. So I'm not completely new to space. A very, very, very long time ago, I did intern at a company called Marconi Space, which I don't think even exists anymore, but I did have some little tiny involvement with some software that was something to do with some European satellites. But now, many years later, I'm nothing to do with kind of space software, but I'm very, very embedded in the world of containers. I work at a company called Isovalent, where we are with a company behind a project called Cilium. Cilium is a networking project very much oriented around containers and Kubernetes. And until last Friday, I was the chair of the Technical Oversight Committee at the Cloud Native Computing Foundation. My term came to an end, so that's 3 years of pretty fun perspective on what's happening in the cloud native industry and the world of containers, really. And I am also the author of a book about container security. The picture in the background is me presenting at a KubeCon event. I kind of have a bit of a claim to fame around writing a presentation where I write a container from scratch in about 80 lines of code. So you may have seen that talk if you're interested in containers, and if you haven't, but you want to know what containers are, check it out.
Thank you, Liz. Next up, Aaron Black.
Hey, everybody. So I'm Aaron Black. I'm out of JPL down in Southern California. I have a couple of roles at JPL. My main role is with the computer-aided engineering group, and I do kind of institutional level project support for shared infrastructure and policies for projects to build on. And as part of that role, I also go down to projects and do some specific setup and help deploy or figure out new technology. So for Mars Helicopter, for Ingenuity, I helped them set up a container that they use to do their flight software builds and analyses that got them shifted off of their dev boxes and got them able to use more of the available compute space on lab. I did the same thing for Clipper and also for FCPL, which is the flight software that Clipper is kind of based on, and then also expanded that out of just the build and analysis, but also into containerizing their simulations, so that when they're running hardware out of loop testing and they're running flight software sims, all those are in containers and can be run in parallel off of the standard developer dev machines. And working on doing the same thing for Sample Return Lander right now. Still in formation though, a little bit.
Thank you, Aaron. Next up, Alan Cudmore.
Hi, my name's Alan Cudmore, and I'm a computer engineer for the Flight Software Systems branch at NASA Goddard. I've been there for about 30 years, and I was born before Skylab launched. I'm not a container expert by any means. I'm more of a real-time operating system expert, but I'm a real fan of Linux and embedded Linux. So I kind of follow the trends and the technology whenever I can. My experience with containers includes an IRAD where we developed a container-based system where we deployed the CFS and a couple of non-CFS containers on a Raspberry Pi to try to simulate a flight software environment. And a lot of that work was done by Christine Carrington, who's now at Ames. Hopefully she's online right now. Lately, I've been interested in exploring the IoT frameworks, such as the Balena.io, which is like an IoT framework for edge computing that uses containers. I think these edge computing frameworks can give us some of the tools we need for our future flight software systems that may be containerized. It seems like commercial industry often provides us with the innovation that we can adopt for flight software. And finally, feel free to stop by Thursday to see my RTEM CFS demo, because I actually use a Docker container for that.
Thank you, Alan.
Okay.
And next up, Luis Rodriguez.
Hi, everyone. So I'm Luis. I work at the APL, at the Applied Physics Lab, as a flight software developer, also testbed software developer, just software developer. And my experience with containers has mostly been around creating this tool that ended up becoming what we call the Avionics Integrated Development Environment, or AID, at APL. And it is a tool based around some sort of container service. So it started as Docker, and then later we transitioned it to Podman, where we use a container network to kind of stand up what we call a spacecraft on a laptop, right? Our SIL environment with flight software running on either a PC Linux container, or now we're transitioning towards, running QEMU inside a container and then instantiating our spacecraft SIL that way. So I don't have a terrible amount of experience. I wouldn't consider myself a container expert whatsoever. I think I've just, like a couple of other panelists, just followed the trends on Docker and started transitioning towards more of a rootless Podman, trying to think more from a security perspective. So yeah.
Thank you, Luis. Next. So this is me. My name is Chris Heistand. I'm the technical chair of the Flight Software Workshop that we're all getting to enjoy. I currently work as the flight software architect at Stoke Space Technologies. I think my claim to fame in the container world is I got to give a presentation at DockerCon 18, where they got to pull me up on stage for some of the work that we did with Dart, and Luis was actually a part of that. So I will be your moderator for this discussion. And next slide. So some rules of engagement. Everybody's been using the question and answer so far really well for all of the other discussions that we've been having with presentations. So the way that this is going to play out, type your questions that you have into the webinar Q&A, upvote what you like. I'll probably pick from the top, and we're going to round robin through the panel. So you can see a handful of questions that I will fill in as we if we don't have enough questions from the audience. But really, what we're trying to get here is what are the things that containers are actually answering for us in space? What are we using them for from a simulation perspective? What is it going to look like on the edge? What are the worries that we have from a security perspective? So as you start hearing things like, hey, what's Balena OS? Ask that question, and we will make sure that we try and answer as well as we can. So open forum, the panelists are encouraged to interact on any topic with each other as well. And so hopefully we're just trying to get an open discussion here. And we already have a question. I'm gonna hold real quick, and then what does the first question that I want to ask, and I think I'm just gonna run down the line. We had a little bit of an intro of what you're doing, but what do containers really enable for your development platform? So if we start with Aaron, Why are you using containers in the first place?
Two main reasons. The first one is kind of to do some work shifting to free up the developer workstations for the focus needs that they need, and to stop having people from doing things like scheduling their regression tests to run off hours on dev machines, because that's the only place where all the software is installed and not everything's available for it. So being able to take those and space shift them to machines that aren't necessarily specifically configured for those tests or for those builds, but can accommodate other builds, because all of the dependencies are in the container and in the environment, and that becomes portable at that point. The side benefit of that portability is it becomes really easy to know what your dependencies are, what's in your environment, and when like 10, 15 years down the line, when you're still doing updates for this craft and you've mothballed all of your old dev machines, but you have to spin something up because you need to do some extra testing. It's much easier to scale when you can just bring up the last working container, and you're off to the races already, instead of spinning up the machines and going and finding the 15-year-old dependencies that you have that you're locked in on, that you can't change because you don't know what that would do to your build and what that would do to your craft. So mostly just the consistency and the place shifting is what we're using it for. A little more around the testing, but I think that's a bigger one to address maybe.
So that brought up a good question of, do we think containers are going to be around in 15 years? That I want to dive into in a second. But next, Alan, can you talk about what they enable on your end, or what your vision is for using containers?
Sure. Yeah, I mean, from a very simple perspective, like my RTEMS demo that I'm going to give on Thursday, I'm using a Docker container to deploy my RTEMS development environment. And what that buys for me is really the ability to reproduce the demo. Like, I always go out to the web and find some neat examples, like of some sort of software application for a Xilinx platform or some sort of RTOS demo. And if it was written a few years ago, chances are that it's not going to build with the latest Xilinx tools or anything. It's kind of suffers from bit rot. And so my goal with this presentation, or with this demo that I'm going to be doing, was to kind of containerize the development environment and use like specific commits of all the repositories that I used in the container. And my hope is that someone could find, this presentation 3 years from now and find the repository and still actually make everything work the same way I did on Thursday. So that's kind of basically reproducibility, I guess, is the bottom line there.
Great. Luis, what does it enable for you?
Yeah, so I think I agree with Aaron and Alan so far, in that reproducibility is a big aspect of it. I think at least for APL, from the space side, right? Because I know containers are used across APL, but in space, we use it kind of in a twofold, which is different, I think, from typically how the industry uses containers. So we use containers as kind of a snapshot, right, of the environment where a specific build product is like produced. So like a development environment. So we provide these containers to all of our developers such that everybody has a reproducible development environment where, if I compile a flight software image, my coworker can also compile the same flight software image, as long as they're working within this same container environment. And we also use containers more as pulling more towards how the industry uses containers, which is a completely isolated environment where you have all the tools to build that flight software binary image, but also I want to be able to run that container without having to, rely in any other sort of environment. I just want that container to be standalone. And so those are two ways in which we use the reproducibility that comes with containers. One is an environment, and then the other one is, I guess, it's a container product that anybody can use, like Alan was saying before, in a couple of years from now, it can be used again, the snapshot, to recreate what was done whenever the image was created.
Great. And Liz, so what does your environment in a non-space world look like?
Yeah, so I was really struck there how all three panelists ahead of me talked about portability across time, really, this ability to go back to an image that, you know, the thing that you put on your spacecraft 3 years ago, you can run again on your desktop. I think in industry, we tend to think of it more about portability between people and avoiding, you know, the works on my machine kind of scenario, that you know you're running the same software that your users are running. Also the multi-tenancy, the ability to have different applications that have different dependencies running on the same machine, again getting away from dependency hell by isolating things to an extent. We can, and I suspect we will get into how strong a boundary a container is or isn't, but at least in terms of distribution, you can isolate what's in one image from what's in another, and that's tremendously useful. I think the third thing that we're really doing a lot in industry is using containers to scale, to have, to be able to go from no instances or a small number of instances of something to many, many instances, perhaps distributed over a lot of machines in, you know, a matter of a very small period of time. So I guess those are the ability to develop fast, the ability to deploy in a variety of environments, and the ability to scale dynamically are really key to why we're using containers in cloud.
Makes a lot of sense. I was also very struck by how much time played into all of those answers. I think that's the nature of space and the nature of our the missions that we have are not measured in days, they're measured in years, right? So I think that's another thing to poke at. Alan?
Yeah, the James Webb Space Telescope is a good example. The ISIM module that we worked on the flight software at Goddard for, the development started, you know, over 20 years ago for that. And I think they went through kind of development hell trying to bring all that software up to kind of the latest workstation. I think they started on like Windows XP or something. And all the versions of all the software that they use, I don't think even really exist anymore. So yeah, that was a big issue.
Yeah. Okay, so I'm gonna start pulling from the Q&A regarding containerization of the flight software payload applications on orbit or during hardware in the loop testing. I'm curious what the panelists think about the issue of interfacing with hardware through containerized environments. It seems like one could find themselves needing a lot of blueware in order to abstract the interfaces to the level I think we typically see in containerized environments in places like web and information technology. And I wanted to tack on one more thing. Alan, you were already talking about how you're doing an RTEMS demo inside a container. And I'm very interested in exploring, is that through QEMU? And so how much hardware, you know, abstraction are we actually putting inside these containers?
No, actually, this demo is going to be on a real board. So the container in this instance is just the development environment. So I'm just going to use the container for actually compiling the code. And that's another aspect of the container, is the portability too, in order to be able to use the same container on multiple development hosts and types of operating systems. Like I can use it on Windows or the Mac or Linux or whatever. And I don't have to rebuild all the RTEMS tools for the different hosts. And one really neat thing I found out recently is that we have one of those new M1 Macs at home. And I found that with Docker on there, I could pull my RTEMS development container and it just does some x86 QEMU magic in the background, and it can actually run my x86 container and build an RTEMS image the same way. So, it's a lot of benefits to being able to run on any type of workstation too, or server, I would imagine.
Just any slowdowns with the M1 piece? I'm actually super interested in Liz's piece here as well, because I think that we just got hit with some M1 latency issues.
Yeah, I mean,
any of that?
I would never want to build the tool chain on like an emulated x86 environment on the M1, but just being able to compile like the CFS on there, it doesn't really introduce that many delays. It's really not that bad. It's not like an order of magnitude slower or anything.
Liz, have you seen the transition with M1s being weird for containers?
Yeah, kind of. So I'll talk a bit about that, and then I want to go back to a general point about the hardware interface. So I got an M1 Mac about a year ago, and it felt like a bit of a gamble in terms of I couldn't run my Vagrant setup that I normally use for demos. I've been using a lot more cloud VMs because I know things are more reliably going to work there. For all we talk about, build once, run anywhere. Yeah, so long as your image has the ARM build as well as the x86 build, then yeah, maybe it's going to work. But certainly, it's a work in progress. But the flip side of this is so many people are buying M1 Macs. Things are moving really fast. But I wanted to come back to this idea of like whether containers affect how you interface to hardware. And I think there is a really, really, really important thing that people need to know about containers. When you run a process in a container from the perspective of the operating system, it is just a process. It's exactly the same. There is nothing. The kernel doesn't know what a container is. What the kernel knows about is namespaces. So it can just say, I'm going to hide some information, not expose it to this process. And it knows about C groups, which is I'm going to hide some resources and not expose them to this process. But the process is just a process. If you're on the host machine, you can look at the containerized processes. They look exactly the same as if they were running directly on the host. So provided you expose your there's no difference in interfacing to hardware apart from maybe a few command line parameters to mount the right hardware into your container. Everything else is the same. So, and it's one of the things that confuse people a lot in the industry. It confuses people about the security model, that it's fundamentally, it's just a Linux process. And if you're comfortable running a Linux process, you're going to get some differences in how you can deploy things, but it's just a process when it's inside a container.
That is great. Really, I love having insight from outside, because I think that the container, the way that a lot of people look at containers is that it's this very isolated piece, and there's a discussion of, well, I mean, are they the same as VMs? Are they the same as Vagrant? And the answer is no, right? Like there's fundamental differences there.
Yeah, exactly. It's much, if you want to get your mental model of what's happening in a container, it's much better to start from thinking of it as a process than it is to start thinking of it as a virtual machine. Even though your experience when you SSH into a container, it looks like a virtual machine, but it really isn't.
Luis and Aaron, have you done hardware interfacing within containers, or have anything to talk to there?
The only hardware interfacing I've done with containers has been through packet exchanges, where the container is running up and is just sending packets back and forth across some network boundary. And in that respect, it didn't behave any different than anything else where you were just sending packets back and forth. We've done some hardware simulations in container running with other processes across some shared memory. And that has been pretty straight. That was just pretty straightforward forklift and run, but I don't think I don't think I've done any hardware. I don't think I've done any hardware in the loop that was that was trying to do like shared memory access.
Yeah, I've actually done that a little bit with the IRAD I had with the CFS. So we were able to talk to some sensors. And in fact, I've been just bringing up this little Balena OS, one of the reference applications they have. I don't know if this shows up, but has a little, I2C environmental sensor that can measure temperature and humidity. And I think they have a way of basically exposing the I2C ports on that device, on their particular operating system in the container. So you can talk to GPIO or I2C or whatever devices you want. I think in Linux, it's generally just file based. So you can just expose access to those files.
And that's basically what device does, right? When you add that to your, so you can just pull in, whether you're using Docker Compose or something like that, you can just pull in devices in that.
Yeah, so at APL we had, and I actually gave a presentation on this like 2 years ago at the Flight Software Workshop. We had like what we were calling a processor in the loop, which was like the same container network that we had where we were running our testbed software, Linux container running the testbed software application, or like, yeah, testbed software. And then we replaced the flight software container with a softcore Leon 3 running on an FPGA. And so we're trying to replace that flight software Linux container with this piece of hardware, right, hooked up to our machines via USB and Ethernet, and then plugging that into the rest of our container network. And so that's as close as I got to working with it. But I did find a lot of difficulties in how I exposed that device, how I hooked it up to the network. And it may have just been lack of experience, I guess, doing all those things. But it ended up being kind of like having to use like Docker machine, right? Like the Docker machine CLI and all that in order to be able to expose the device. And this was a couple of years ago, so maybe things have gotten better, but I did find it difficult to kind of interact with something like that, right? An external piece of hardware that I want to be part of my container network, just in terms of probing the community for things like that. I found it a little bit difficult.
Yeah, I think that going one extreme of you can expose ports and that's all you get, and the other extreme of you're running this on your edge computer, and that edge computer, it is like you're treating it as an embedded piece, and you're actually running on board. I think that both of those extremes are handled pretty well with being able to volume in whatever you need to. And then the intermediate where you're trying to run on your laptop, which has a couple of different layers that you're trying to work through regardless, talking to hardware becomes an interesting middle ground that I don't think is necessarily solved yet.
Yeah, absolutely. If you're running Docker on a Windows machine or Mac, you have got a virtual machine there. So you've got a very different boundary to cross to get to hardware.
WSL2 has like made ginormous improvements from what I have seen a couple of years ago, and that actually has been a lot better. I think that the M1 step has been interesting to handle. So we used to have Linux. It works. That's fine. Mac was the almost supported, and then the Windows side was the stepchild. And I think that the Mac and Windows has somehow flipped. Okay, next up, sharing image containers is one of the greatest features for collaboration in our community. How can we openly share images while keeping export restrictions in mind? So I also want to like open this up to the security question. When developers talk security, containers are great and like a really wonderful tool to isolate a bunch of things. And when your IT team talks security, all of a sudden they're like, you can't use any containers. They're very scary. Things go on underneath the hood. We can't see into them. So I want to open up that question as to how do we share and what are the hurdles that you've seen from a security perspective?
So I'll jump in. In terms of sharing, I think that is a very difficult question to answer just because there's so, like you said, there's so much proprietary information and stuff like that, that it becomes really difficult. Like we can share base images, right? But we can't, I feel like it gets a lot more complicated when you're trying to share, you know, an actual build product from some project, right? And so like typically, at least at APL, what we've resorted to is just, we share containers, but just across our organization. And so we use like private registries to do that, right? To share images across developers and not have to have other users build an image from scratch. Instead, just pull an image that we've pre-compiled and uploaded over to Artifactory or whatever it is. So from the security perspective, though, I do find that like very interesting. I think that I'll address the biggest scare, I think, for almost every Docker user is this Docker daemon running as root, right? And how you control what the Docker daemon can do, and the fact that the containers are being orchestrated in some way by this root powerful Docker daemon, right? And I'd say that I guess we took the kind of easy way out by just going to like rootless podman, right? You get rid of the Docker daemon altogether, and then you can control containers a little bit more and limit their operating space, I guess, to just the user. So to the user that instantiated the container. So that's, but maybe there are better ways to do that, right? With Docker, I think that's typically what scares people, though, that this Docker daemon process is running rootful.
Aaron, have you had to from JPL's perspective, have you run into that rootless root discussion?
We've run into people. I mean, running rootless is something that we want to do. The bigger problem is just containers running as root themselves, not like containers not even defaulting to a non-user profile because that's how they're built. And in industry, like, why would you care? But when you're volume mounting a bunch of stuff in, you're running as root, then you wind up leaving a bunch of root-owned files around in your volume mounts, and cleaning those up is kind of a giant pain. That's not, when you're running it in a shared space, you can do some scary things with root, and we've mostly worked around all of those. But it's not just that the daemon's running as root, it's that you're running as root inside the container, and there's kind of both of those layers that we've had to deal with in order to make containers really functional in a shared workspace kind of capacity. Back to the sharing question, though, I don't really think we have anything to add that Lewis didn't. The sharing that we do is mostly intra-organization between projects that all, because our containers have licensed compilers in them, and there's not a ton of external sharing we can do with those. But I don't know that that's a container problem so much as a licensing problem.
So Liz, in industry, does everything run as root?
This has been the biggest problem from a security perspective in the whole kind of cloud native industry. I think probably 3 years ago now, I did a whole talk about running with scissors, which is effectively you're running as root the whole time in containers by default. And that root, like I said, it's just a process. And if you're root in a container, unless you're running rootless containers, root in a container is root on the host. And if you escape that container, you've got everything. So we do care in industry, like security is a thing. We are bothered about that. It does make a very big difference. The context of your application. I can talk for an hour and a half probably about different ways you could secure your containers, and I could tell you some things that will make it a pretty strong boundary between one container and another container running on the same virtual machine or physical machine. I do not want my bank running anything in a container on anything shared with, with my money being processed in a container shared with anybody else's processes. Containers are not a security boundary in themselves. You can do a lot to harden them, but you are still fundamentally sharing a machine. So you've got to have some confidence that people that you're sharing that machine with are not actively trying to do bad things. I think when it comes to the images that we're sharing, one thing that's very common sort of best practice is you don't build anything into an image that's a secret. Now, I'm not really talking about proprietary code, but I'm talking more about, the tokens and keys and things that we were taught with 12-factor app that you should pass into your application at runtime. That continues to be true. You should pass them into your container at runtime rather than building them into your image. I was also really interested to hear, we're building compilers into our image, and that makes me instantly nervous because it means that the code that you're running in your container, well, hopefully your build is a reproducible build, but I'm constantly telling people, make your containers immutable so that everything you have running in your container is a known entity. And then you can use tooling to identify, for example, if you find an executable running inside a container that wasn't there when you built it, that's a bad thing. And there are tools that, will detect that this executable is not the same binary that was in the built image. So we should, alert or kill it or do something because it's malicious. You can't do that if your containers are not immutable.
So I think, Alan and Luis, I'm interested in what does a build actually look like? Because to Liz's point of immutability, I think that our goal is generally immutability in the container, and then it is building on the outside with a volumed development environment. Is that, did I get that right?
Yeah, that's the way I approach it with, for example, in the demo that I have, it has the RTEMS cross compiler in it. And then of course, the base container image has all the compiler tools that build the cross compiler. But my goal is to use it in such a way that I just mount the volume for the host and then download the code in the host that I want to compile and just use the compiler just as a tool in the container. And then when I exit the container shell, it just kind of goes away, and any files that were created, if there's any temporary files, or will just be destroyed. So yeah, from the perspective of that tool, it's really just like a temporary resource to run the tool long enough to compile the code that I need. But yeah, it's really interesting. Like I'm curious, like some organizations like Goddard, they try to approach the containers we use almost like it's another machine that needs to be administered. And so, a tiny Debian or Ubuntu container that's normally like 100 megabytes or two ends up becoming like over a gigabyte with all the required IT support tools in it by the time we get to it. So that's really a big question for me, is like, how do we approach containers if we're just using them for, like little experiments? Like I want to see if I can run the CFS in this container and then just throw it away. I don't want to have to like bring up some huge gigabyte container to do that because it has all the proper IT tools in it.
Yeah, from just to add on to what Alan said, from our perspective, it's the same thing, right? That was that difference I was trying to make between like production, here's like everything you need to run flight software, to run testbed software, versus here's the environment you need in order to build a flight software or testbed software development image, right? We're passing around some container images as these are the environment, these are the tools you need in your environment to compile. And again, you volume in your source code, you compile, you spit out the same volume, the binary product. and then you shut down the container, right? And then there's the other version of it, which is, okay, now I want to run that binary of testbed software, say, inside my container. That container will be up for longer, right? It'll be up for the lifespan of the SIL environment that I'm using, the software in the loop environment I'm using. So it's kind of two different versions of it. But yeah, that voluming in is the development part. I wanted to mention from the security perspective, I think it's also interesting that, you know, it sounds like from Alan and Aaron, these environments we bring up to compile our images are quickly shut down after we get what we want, right? We get it out the same volume, the binary product. I think, and Liz, I was interested in your opinion on this. I think in the industry is usually like these containers are running for a lot longer, right? So they're exposed to security concerns much bigger than in our cases where we bring it up, right? We run a tool and then we shut them down. So they're kind of, you know, they're up for such little time that everything inside the container is going to be terminated very soon. And that's not always how we're using them, but I think it's a very big difference between how the non-space industry uses the container tools.
Yeah, I think that is true. I mean, we do use containerized builds and compilers to emit a container image that we then run, you know, somewhere in a cluster of machines. The typical lifespan, I believe, is about, or the average lifespan of a container in a sort of deployed platform is, I believe, around 2 days. And so that is kind of plenty of time for an attack to take place, and also a really, really short period of time compared to, you know, long running applications that organizations would have traditionally been running. And a big part of that is because of the scaling. You know, if we're constantly scaling the number of instances up and down, the first one to arrive could also be the first one to, you know, it's not completely random, but, you know, you can very easily end up with a different set of containers every day or every hour, or, you know, so that does change changes some of the rules of engagement for attackers, I suppose.
Taking another question from the audience, what experience or thoughts for using provisioners like Vagrant for these containerized environments? So there was already mention of using VMs and then containers on the VMs. What does a typical environment look like? And where do VMs play into this virtualized system?
We have a small set development environment, the NAS Cubed, which some of the people from the Goddard IV&V facility in West Virginia might have talked about in previous conferences. But their environment is a VM-based development environment, and it's brought up using Vagrant. So I don't think they've really taken the step over to containers yet. But we regularly will bring up that environment using Vagrant and, I guess, VirtualBox.
And are you, when you're deploying these, are you usually on personal laptops, or are you on like a cloud hosted set of VMs or a cloud hosted set of bare metal? What does container and VM ratio look like to you?
Well, the use case for the small sat development environment, or the NAS Cube development environment, is really just like a developer workstation. I don't think we've really done much to get it into the cloud or that type of environment, or like a cloud server or VM server or anything. But we also do use VMs, like hosted VMs, as development machines in our organization, and those are completely managed as if they were, a separate Linux workstation, and they're up for the duration for developers to use.
JPL, is that similar, Aaron?
I don't deal with Vagrant or VMs directly with our container deployments. If you have a VM that's up that has all of your dependencies and all of the other software you need to do the build or to run the simulation, you don't need the containers that have those things in them anymore at that point. So, I mean, developers will use VMs that are provisioned like regular Linux machines, and they'll do a lot of primary development work on those. The container use case is primarily for scaling off of those things, for when we have a lot of tests that we need to run. The resource requirements of those tests are such that we tend to match each compose stack to its own machine and just scale up and down the cloud instances of the machines. We did some work with them in Kubernetes a little bit, but there's some mounting annoyances in Kubernetes that made that not ideal. But mostly we wouldn't spin up a VM just to put a container on it. We would have the right VM spin up on its own.
When I very first got into containers, there was a whole thing in industry of people who were currently running, in the cloud with virtual machines, and the amount of energy and effort spent taking those applications, putting them into a container, and then just running the container on the VM again and having like one container on the virtual machine. And it felt like a really, really long period of time. I was like, why are people doing this? What possible gain is there of this? I think it was really just a stepping stone. But yeah, I don't know why people would do that.
So I'll just add that at the very beginning, back in 2018, I remember at the DockerCon in 2018, they mentioned that Docker was, like working more closely together with Windows to create a better product, like a Docker desktop that was a little bit friendlier to the user. But I remember back in 2018, Docker was not in a place, I don't know about today, because I just shy away from using Docker in Windows altogether. But using Docker in Windows, at least 4 years ago, was so rough that I remember people just spinning up like VMs in their Windows machine, like a Linux VM, so that they could run Docker inside of it, right? And technically that's what Docker Desktop is doing, right? So, but yeah, I feel like at the very beginning, those were stepping stones that you kind of had to figure out, like, is it worth it for me to run, like, to containerize my applications, to run them inside a VM on Windows inside a container, right? Yeah, so I just found that interesting. Like, I found that as a necessity back then. At APL, we kind of migrated to this, like, have your development environment in in a cloud VM, and then run your containers in there. And I think that just streams like the whole installation of, like, whether it's Podman or Docker or whatever it is. And then we focus on the containers being just an easy way for you to download an environment to do your compilation or whatever. And then also to create this like container network, which then we have complete access over how to instantiate and how to tear down and be able to reproduce say it's a test, like reproduce a test that we were doing on the software by instantiating the container network and shutting it down, right? And I believe it's still worth to use containers in a VM in that way, because you have complete control over that, the instantiating and tear down of a container network, right?
I think that kind of brings up a point of testing and the fact that we are building very coupled systems with an environment that we're emulating, right? And so it is not like we're deploying a single container that's the database, and then you deploy another container that's your web server, and then they can talk to each other and you can take one up and put one down. It is generally something where when we get into a true software in the loop system, you have a container for flight software or a container for every single piece of hardware that you're emulating, and then usually a container for environment and maybe even a container for ground software. And so that collection of containers and the orchestration behind that is where this becomes, like, I think there's a general use case in space there. we have
This
11.
explains why Docker Compose came up earlier on.
That is
When you talk
exactly
about it like
why.
that, I get it now.
So that is, I think that our initial foray into this is usually, hey, we need to define how we're going to bring up an instance of the overall system with n number of containers. And then there's this question of like, okay, we can do one scale, because scaling from a Docker Compose that's being able to do one, you can do tricks like randomize a hash and append that to the project name, and then you can do a handful of these. But that's not the way the industry has gone, right? The way the industry has gone is like a true orchestrator and from Kubernetes or something else. And so are there plans to scale, or for your current use cases, do you need to scale from where you're at right now? And I think that's a lot to Aaron and Luis.
Very yes. I mean, but a lot of the scaling we're doing with Compose in particular is things like here's a container for the ground system, here's a container for the flight software, here's a container for the hardware simulations, here's a container for the database, here's a container for here's some tests that we're going to volume mount in that we want to run against it. These tests take a couple of weeks to complete if you're running them on one machine, but you can break them up into, I mean, they're just long running integration tests, and you can break them up and you can spread them out and scale them out, and being able to run that, like this volume of integration tests in this duration, like you need to scale that to get them done in any reasonable time frame. I mean, you're not gonna waiting 2 weeks or cutting back on the tests that you're running, just it doesn't help you write good flight software because you don't have the resources to run all the tests you need to run. So we need to scale up just to get the testing done that we want to get done. And there's enough pieces developed by enough different people in that as-built spacecraft simulation, or as Luis would say, like the spacecraft on laptop. Like there's enough different pieces in there that Compose lets us hot swap. Like, well, this stack needs a different version of this stuff because it's ready now and it wasn't before. So like Compose is just a convenient orchestrator for that. And we tested orchestrating that in Kubernetes because we need a bunch of copies of that stack just with different inputs and different tests to run. It just didn't work like it needed to.
Yeah, from a scaling perspective, I think, we provide these sills as a development environment for each developer. And in that sense, we don't need to scale, but there's definitely a scalability question when you start thinking about your CI pipeline, right? And you wanting to now instantiate these multiple container networks in multiple agents, like CI agents, right? And to run the tests like Aaron is talking about, like automated testing, right? In these like instantiated container-based sills. And so I don't know, I don't feel like I'm well equipped enough to know, like, there are ways for us to do that, to have the CI agents run multiple container networks using something like Docker Compose, because I think where Kubernetes, and maybe this is my lack of knowledge, but where Kubernetes really becomes powerful is when you're running these things across multiple like machines, right? But if the agent is just managing its own like environment and it's just instantiating a host in that environment, and then another agent spawns in another host to instantiate another set of containers in its environment, then I guess the CI agent orchestrator in a way is the one managing the deployment of these multiple container frameworks or networks in different places. I don't know if I explain myself correctly, but yeah. So I don't know. Right now I don't know. Maybe in a couple of years we'll need to. Yeah.
So speaking of CI/CD, is the standard CI/CD model good enough for version controlling your containers before deployment, or is there a better way? Is there any other way? think that this is a question of when you're building. I think that generally there's a concept of build containers which have all the things that are required, and then production containers that have the actual output. And I don't even know if those are like the right terminology in industry, but I think that that's one of the ways that we've talked about it a lot in space. Is the CI/CD model the right way to handle that? For tagging containers, understanding what you have, pushing to registries.
I could say there's a couple of things that I think historically were not great decisions in the design of particularly container images. So one is, and they basically come back, or they result in it being very hard to do reproducible builds. So things like timestamps be included in what ultimately gets hashed into the image ID. So if you build exactly the same code with exactly the same tools, everything is, bit compatible, except that you ran it at a different time of day, or on a different day. Yeah, and those two images, you can't tell by looking at the images, from the outside. You can't tell that they're basically identical. So that was a bit of a mistake. And the other thing that is has led to all sorts of hijinks and fun and games is the fact that you can tag a container image. Those tags are mutable. I can give you an image and I can change the tag on it, and you're none the wiser that it's the underlying container hasn't changed. So by and large, best practices, once you've decided what container image you want to use, you refer to it by its hash, by its SHA, which kind of means, once it's been built once and you're happy with it, that's the image everybody's going to use. And I think probably this is makes a lot of sense in a Kubernetes environment where we might have that one instance built and then run it in 1,000 different places. Which is probably a different problem from the problems that you're doing in flight.
So going off of tags is not an industry standard practice.
It creates all sorts of problems. So say you have my app version 1 and you've tagged it as 1, but did you really mean 1.0.1? And what if I come along and I say this is actually version 2, but I didn't recompile it. I just said it was version 2. You can just, that they're completely insecure. The only secure way of identifying whether an image is the image you think it is by knowing the hash of it.
This is very relatable, Liz.
I see smiles because I think we've all been hit by that. Was there any time you applied a container to a situation and later thought that was a waste of time? When is the complexity of setting up and maintaining a container worth it?
I'll go ahead and start. I've never thought it was a waste of time. But there are definitely use cases where I wouldn't spend the time. But I think, if you know for sure that you're only ever going to be doing it on your one machine, or when you're still in the prototyping stages and you're still figuring out what you need, like before you're at a point where you need it to scale or you need it to pass off to someone else, it's probably not worth doing then. But if you ever, like once you're past that, if you know what you need to do your thing, to do your work, and you know that you want to, and you know that you need to move that to systems that aren't necessarily managed by your team, like to someone else's laptop or to some shared build infrastructure, or some CI system that is not going to have any of your tools on it because you don't own the CI machines. Once you get to those points, then it's worth considering or doing. But certainly before that, you should figure out what you need and whether you need it first.
Anyone else want to chime in?
I mean, I don't have any personal experience. I haven't built too many containers, but I have seen out there where like a project, like for some sort of RTOS or framework, will at first produce a development environment using a container. And I've seen them in a couple of instances where they kind of back off on that strategy and either just give you tools to just building everything in Ubuntu or showing you how to build it in a VM or something, where it makes me wonder if maybe a container wasn't the right solution for, putting what ended up being a pretty big development environment.
So it is 10:30 and we're gonna have to close this. Any closing remarks? There's so many opinions and so many questions, but I think that we can probably pull these over to Slack and keep answering them. Yeah, any closing remarks before we close up?
I would just say that, for one, ignore all my bad practices in the container that I created for my demo on Thursday. And two, that I'm looking forward to more talk about really using containers on embedded devices, especially as I think they're going to be used on flight systems sooner or later.
I was going to just throw in a quick plug for my talk on Thursday, where I'm not really talking about containers, I'm talking about eBPF, but I think there's some really interesting I got into eBPF because it's really interesting for instrumenting what's happening on Linux, but specifically on containers. So come to my talk and ask me more questions there.
Lisa and Aaron?
Containers are scary. Be very afraid. But also they open up a lot of possibilities and a lot of different ways to work and a lot of scaling options that I don't think a lot of space development is traditionally used to. And I think it's worth kind of figuring out what they are and how they can augment your workflows and help us build better stuff by scaling up the stuff we're able to do before it gets up into orbit or up into transit, and when it's really expensive to fix.
If you're stuck, containerize it. I'm kidding. Yeah, I just think, containers enable a lot of things, and they are scary, but where they make sense, they can really enable a lot of just collaboration across the same team or reproduction across your CI pipeline and just a regular developer. So if it makes sense, even if it's scary, just go for it.
Thank you all. Thank you, panelists. And yeah, so we're going to continue along with the Flight Software Workshop, and come find us on Slack. Let's keep the conversation going. Bye, everyone.
All right, thanks.
Thank you to everyone for that wonderful first town hall of the workshop.